Hello.
Howdy.
Just give it a couple more minutes here for people to trickle in. I will set up screen sharing in the meantime.
Thank you.
Was anyone here able to make KubeCon? Laura, I know you were.
Yeah, I was there. I saw Lewis too. So
Yes, I was there. Sorry, my audio was screwing up, but hello.
Awesome. Was it fun?
VX.
KubeCon was great. Yeah, sorry, I missed whatever the conversation was before. But...
Yeah, no, I was sad I wasn't able to make it in person this time. Hopefully, hopefully the next one's back to more normal.
It was definitely intense going to like a huge conference center after like a long time of not being in a room like that much bigger than my own room at any given time. So
right.
so, yeah.
Yeah, it looked pretty packed.
It was a big change to the norm and stuff, but it's nice to be back at some talks and things though.
Yeah. Awesome.
Talks being hosted in person too, because they were like just on the jumbo screen, you know. So, but it was a bigger monitor than I have at home, so there's that.
Yeah, that is nice. All right, so we're 4 minutes after the start time, so I think we should get rolling. So welcome everyone to the SIG Multicluster meeting for Tuesday, October 19th, 2021. I think we have a couple things on the agenda today. Laura, it looks like you could use a refresh. I'm assuming that's you presenting. But you are first. So Laura, take it away.
All right, I'm taking it away. All right, so I mentioned in the Slack yesterday too, but I wanted to talk today about multi-cluster topology aware hints. And I'm going to do kind of a little like refresher / intro for anybody who doesn't know about what's going on with topology aware hints single cluster. And I also invited Rob Scott from SIG Network, who's the author of that KEP, who I believe is on the line now. Hey. Rob. And yeah, so I'm going to talk a little bit about that. And then I kind of just want to open the floor for, here, I'll even go to my agenda page. How about that? I want to open the floor for discussing what this existing in single cluster means for multi-cluster services. We've talked about it very briefly in the past, and there is some language in the KEP on it too that, you know, we will support basically topology aware hints at some point, but that it was currently in flux. So I think, you know, it's less fluxy now. So I'm going to present sort of like what the unfluxy situation is right now. And then we can decide, you know, if we need to do anything specific for MCS, if we need to advise something specific, if we need to say anything specific about implementations or about how this integrates with single cluster and how it changes or doesn't change for multi-cluster. And I have some like seed questions at the end, but yeah, I'll stop talking about the agenda and just talk about the thing now. Okay, it wouldn't be Laura Loren's slides if it didn't have a bunch of Google Slides clip art on it. So here we are. Basically, the idea for single cluster topology aware is to try and address this question. If you're a client inside this cluster represented by the circly smiley man, smiley face is what this is called, you have a cluster IP service, you might want to ask yourself, what backend should I go to? Generally for cluster IP services, the idea is that you like randomly pick, or it's randomly picked for you. But the question was asked in SIG network, could we be smarter about that? Could we go somewhere more specific? So this topology aware hints proposal, there's even more backstory before this kept that I actually don't have all the history on, but this is the current proposal, which is alpha in 121 and intending to be beta in 123 this December. Prayer emojis for that, going great for everybody. And the idea of the topology aware hints kept in short is kind of, there's two pieces to it. One is that it provides this new field down here on endpoint slices. So this is endpoint slice type that can be a string that's some type of zone. And the idea is that each zone's cube proxy, so like a cube proxy running in zone A, will look on endpoint slice, see if that endpoint slice has zone A annotated on it, and we'll be like, okay, cool, I will program this in IP tables because I'm zone A, this backend is for zone A, we're all friends, right? So that's kind of the first half. And then the second half of the topology aware hints kept is that it also provides a way for the endpoint controller to automatically annotate endpoint slices with these hints. So you, a human or some other tooling, wouldn't need to attach this. There's an auto algorithm that was decided with SIG network that for all the endpoint slices, we'll make a decision of, is this the one that's for zone A? Is this one for zone B, etc. So back to the diagram, our happy client could be like, oh, this one is for zone orange, and this is I'm in the orange zone, so I should totally go there. So that's the idea. So to speak a little bit about the auto part, I included some slides to explain this, just so we can decide if this is relevant for us in multi-cluster too. But the auto behavior to automatically add annotations to all endpoint slices is based on an algorithm that's emphasizing the capacity of each zone. So the idea is that more client traffic is likely to originate from zones with bigger or with more nodes in it. So that zone should have more backends allocated, annotated with that zone. So there's some like actual words down here from the KEP, which I've also turned into some diagrams. So I'm just going to show those diagrams here really quick so we can all be on the same page. So in general here, if we have this blue zone, this orange zone, and turquoise, teal, maybe teal, greenish zone, if they all have the same amount of CPU, like this is 2 CPUs, 2 CPUs, 2 CPUs, from the perspective of the auto algorithm, these are all equally likely to originate client traffic that might want to go to one of these backends. So each backend gets, or each zone, the teal zone, the orange zone, and the blue zone, get equivalent numbers of backends annotated with their zone name. And one extra sort of point that's in the KEP is that endpoints are preferentially annotated for the same zone they're in. So in this situation, if we've decided everybody's even, so everybody gets 4 endpoints because we have conveniently 4 endpoints everywhere, then they all get annotated basically with their same zone because they will try and choose its own zone. So this client here, we think that there's going to be sort of even client traffic from all of them because they have the same capacity. So this client here will talk to its blue zone backends. This client here will only ever talk to its orange zone backends, and this one will talk to its green zone backends. So where this is different is if one zone has more capacity as judged by CPUs. So this could be because this is a bigger node for some reason, which is how I represented this in clip art form, or it could just be that there's more nodes in this zone. So then the algorithm needs to basically give 2 times as many backends to the blue zone annotation, because it has 2 times as much capacity as the other locations. So this is the part that kind of sometimes feels confusing, but the effect here, since we need 6 endpoints for blue, 3 endpoints for orange, and 3 endpoints for teal, is that we're going to have to go and grab some endpoints. And by grab, I mean we need to annotate this backend as destined for traffic from blue clients. This one, even though it's over in the teal zone, destined for traffic from blue clients, because we need to allocate 6 endpoints to this blue zone. So hopefully the pictures helped a little bit explain how this auto behavior works. And again, this auto behavior is sort of half of the whole thing, right? Because just going all the way back, there's 2 pieces to this. The fact that this field exists at all, that anything, any person or any tool could fill this, and that there's this single cluster auto behavior that operates the way that I just explained. Okay, so
it looks like we have a question from Nathan.
Oh, yes. Tell me the question. Hi, Nathan.
Hey. So just so I understand, so like it sounds like this really only the algorithm only drives where, like, which endpoint slices get the annotation. Like, in other words, like, yep, from the Istio perspective, if Istio, obviously needs to know all of the endpoints because it kind of implements its own load balancing algorithm. Will all endpoints still be available?
Yeah, they're entirely available. This is really just a hinting system that can be useful. We're using it for kubeproxy. It can be useful for other systems. Like, I think that's why we're talking about it at multi-cluster. This is something that seems like it could potentially be useful for multi-cluster use cases as well. But it's really just an annotation or extra bit of metadata per endpoint. It doesn't affect. You can still get all the endpoint slices if you want them. There's nothing to prevent that.
Got it. Perfect. Thanks.
Cool. Thanks, Rob. Okay, slight pause for any more questions on the starting point, but this slide here is kind of my seed for what I think we might be concerned about for multi-cluster, and then I basically want to open the floor to debate on this. So this is kind of dense, so but I'll kind of go through them one by one, and these are just the things that I'm thinking about, and then we can also talk about anything else anybody else has on their mind. So I think some like just basic questions is, if this is a property that's set on a service, which it is, there's a annotation that goes on a service, is that something that we need to carry over to our service import, or say in the MCS spec that we need to carry it over? Do we suggest any auto behavior at all from that is like, or any auto behavior period? If so, is it different from single cluster auto behavior in any way for services that are MCS? So one interesting thing about this auto implementation as it exists today is it needs to know stuff about like all the nodes, right? And right now, the way that it's going to be designed for a single cluster is it's going to know everything about the nodes in one cluster. But obviously, if we're multi-cluster, there's nodes in other clusters to consider in terms of capacity planning if we were going to be mimicking it directly. So if nothing else, if we were going to try and extend the auto behavior, like suggest that multi-cluster service controllers extend the auto behavior in some way, then something would need to operate at the MCS controller level in order to aggregate these zone aggregations across the whole cluster set to make that type of holistic assignment decision. And then another idea that has come up in talking about this with people is if we didn't necessarily do anything special for these allocation hints, these topology hints. There we go. From an MCS perspective, but just like copied over whatever the single cluster case had. So like if somebody decided to put topology aware hints turned on in a single cluster, and we pull those over for any exported service, and that information is still annotated on the endpoint slices in another service. You know, do we want to say that's how that should work in the general, like just out of the gate? And then are we concerned about any of the potential side effects for that? So one thing is that the hints are wrong potentially because they couldn't take into account, if they were designed for single cluster, they're not taking into account the potential like client traffic capacity likelihoods, I guess, right? The proportion of client traffic that we're expecting based on this algorithm from the other cluster where the service is exported, where we expect client traffic to try and contact these backends. So is there something we should like warn people, or like, should we do something about this? So just a couple more slides here of this specific cases. If this is our cluster set here and we export this green service over here and it comes with its location and annotation, or sorry, if it comes with its topology hint with it, that's like, oh, I'm a backend that should respond to blue clients. Then if we have a client originating in red and it's like, oh, nobody is from red, then, you know, what do we do? Is this, are we cool with this? Is this the way that, you know, I guess, like, do we accept this? Is this something that we feel we need to warn people? So I know I just said a lot of words, and I kind of want to open the floor. And there's like many tiers of like, we could just say, you know, we'll route based on annotations if they're there, and then we don't say anything else. We could say we'll route based on annotations if they're there, and you should watch out if you like have a export into clusters that don't have the same zones as your source cluster. We could do something more intense of having an auto behavior described for MCS that is similar or very different from single cluster. So those all seem like possibilities that are on the floor right now. I will pause now.
My understanding of the implementation is that if there was no for zone for a specific zone, you would just get all endpoints. Is that?
Yeah, that's accurate. So if there are a lot of places where this just bails out, and that's one of them. So if it can't find any endpoints that have been allocated for the zone of the originating traffic, it just round robins across all. You know, standard behavior basically. So it will only do that if it will only route to a subset of endpoints if it can find a subset of endpoints that make sense to it.
Okay. So that alleviates some of the pain.
I have a question about that may be really specific, but the way I read it was that like up on this one, that the way this is actually implemented is that kube proxy is just going to like not program IP tables for endpoints that don't match the zone. But then if there wasn't an endpoint for every zone that the endpoint controller knows do exist, then it just doesn't do it. Basically is as if it was disabled. So yeah. I don't know if that's a relevant point, but basically if a multi-cluster person shows up and like now added some zones basically that don't like don't have any of their own backends, which this is kind of questionable because this is like a, you know, shadow backend here, but don't have any of their own backends, then it basically turns off like turns it off entirely, I guess, is how I read it. Is that correct, Rob? I guess.
Yeah, you're right. That's a really good thing to call out. So right now, this is obviously an alpha and going to beta, but we're trying to be very cautious and kind of bail out and fall back to default behavior as quickly as possible. The concern is that if we, you know, when you're operating with a subset of endpoints, you're increasing the likelihood that you're going to overload those endpoints. So imagine kind of this worst case scenario where you have, you know, 100 endpoints for a service, but only 2 of them have a hint for your zone. But the rest just don't have hints at all. If you only send traffic to those 2 endpoints, you're probably going to overload them. Some real world examples of where that could be true is when you're transitioning to or from hints being enabled. In those cases, you kind of have a partial subset, and you don't really want to or at least you don't feel confident routing to that subset unless you can tell, okay, everything for this service has hints, so it's probably fully set up. And if it doesn't, it's not, so let's just not mess with it. Those are some strong assumptions, and very open to feedback on if they are reasonable. But right now, I'd say in general, the Kubernetes implementation, single cluster Kubernetes implementation, is pretty cautious. Whenever it comes to anything that seems a little bit off, it will just bail out.
Hi, Nathan. I see your hand.
Yeah, so I guess I'm just struggling to understand why we just don't label the endpoints with their locality information like we used to. Like
Yeah.
how, like it seems like that's the raw data, right? Like
right. You're right, and we do. We still do label. We still do have that label or field, I guess now. The problem with what we're trying to do here is that single cluster Kubernetes load balancing is, kubeproxy cluster IP load balancing is by its very nature decentralized. So you can't make those kind of, or it's significantly more difficult to make those kind of more nuanced decisions about, I'm going to allocate this endpoint from another zone over to help balance things over. And we also don't have a great feedback mechanism, a great feedback loop as far as whether an endpoint is overloaded. So the best we can really do with the limited capabilities we have right now is delivering a proportional set of endpoints to each zone. And that's really all hints is about. It's just we're going to chunk these endpoints up so each zone gets a proportional amount of them. And that's not great, but it's at least a slight improvement over status quo. And there's still lots more room for improvement. Like what I see as a potential, I'm not familiar with every multi-cluster implementation out there, but there's a lot more room to build more advanced topology aware routing out there, and I don't want this to be any kind of limitation on that. This is just, from my perspective, a good enough approach that works within the confines of Kubernetes single cluster IP load balancing.
Got it. Yeah, I'm obviously I've got my Istio glasses on, and I'm looking at this and wondering, how do I care? And I think the answer is no.
Yeah, I think that's accurate. Yeah. So the one thing I would say, and I think Laura called it out here, is that one reason you might care is if you're mirroring endpoint slices across clusters. I don't think you are. I'm not sure, but I think some implementations are doing that. And you may actually, if you're mirroring endpoint slices over verbatim, you may actually want to remove those hints because they're not very meaningful when you're pulling them from another cluster. So that would be one reason you may want to care.
I think that was actually one of Laura's questions here for us. And I think you actually just kind of gave us the answer, Rob, for on slide 11.
No.
That last one, yeah. Should you, if you're just mirroring endpoint slices, should you copy over the hints? And I think it's pretty clear that the answer is no, because those hints were populated with partial information.
Yeah, exactly.
And,
I mean, if hints are helpful, you can recalculate them with a multi-cluster view of the world,
right,
in something that makes sense. But hints that were calculated with a single cluster view of the world are going to be rather unhelpful and confusing if you mirror them over without any modification.
Right. And then kind of working backwards on these questions, do we suggest any auto behavior? Like, I think philosophically, probably not. Like, what does that look like in a multi-cluster? And I think with MCS, we've had a pretty solid stance of letting implementations figure it out and leaving room. So I would suggest we probably don't suggest an auto behavior, just say that we support this feature and implementations are absolutely free to provide, intelligence using it. So I'm curious if anyone, has another opinion there. But I think like that first question is the one we need to think about. And so pause for a second to see if anyone disagrees that and would like to see an auto behavior specified for MCS or just allow support. Cool. So if we're all on the same page there, that'd be awesome.
Yeah, so just to say that again and to summarize for everybody, just the half of this that's about like putting this on here automatically for people, putting this zone annotation automatically on for people, sounds like something that we don't feel MCS API needs to be prescriptive about. But we are talking about this side where if somehow some labels got somewhere, then we want to be able to support them. We want to be able to preferentially route as the hints are trying to tell us to, I guess.
Yeah, so this is my perspective, and I'm not as familiar with MCS by any means, but I feel like the two areas we could potentially be prescriptive are really what we talked about already. Is one, if you see a hint that was generated, with a single cluster view of the world, you should not mirror that across to other clusters. And two, you are welcome to add your own hints that may be meaningful in the multi-cluster context, but we don't need to be more prescriptive than that. I think that's maybe a reasonable balance here, and I think lines up with what you were also saying.
Question or hand rather from Ryan. What's that?
So yeah, I'm kind of new here. Just kind of maybe a newbie question. So in the case, Laura, can you go back to your slides, maybe 10? Yeah. So in the case that the blue zone is bigger, right? So if we have blue and the yellow both export and service, same service, and the green is having import of this service, I wonder how does the green know the blue has more nodes than the yellow ones currently? Are there any hint or ways to do that, or it will be routed it will basically load balance to the pod in the end, or it will load balance to the each cluster first and then load balance after that, which could lead to imbalance there. I don't know if I
Yeah. Go ahead, Rob, or I can.
Yeah. Well, no, that makes sense. I think that most of this diagram was referring to a single cluster use case, where we do have this kind of context. It's relatively undefined how we would handle this in a multi-cluster use case right now. Which
my question is more about for Laura or for the implementations. I think GKE has an implementation and the Submarine has so what's the current implementation in the multi-cluster way to handle this? Basically, do we need an extra hint to make it really load balanced, or we don't?
Yeah, right now there's no hints yet at all.
And would that lead to imbalance, or it will naturally balance to the pod level, or it's just balanced to the cluster level?
I think if I am getting it right, it's basically just going to do like round robin. Submariner's a little different, but just basically going to do round robin across all of the exported backend. So like in this example, I'm pretending that like this cluster doesn't actually have any of its own. It only would bump over here. So it would like go between these. It doesn't know anything about these hints yet. That's the part under discussion. If instead this was like actually a backend in here, it would bounce between this and all of these guys if they're all exported. Even if your client is coming from, I lost my smiley face, but if your client is coming from over here. For Submariner, Stephen, correct me if I'm wrong, but I think it prefers cluster first, cluster local
Yeah,
first.
that's right.
Yeah, so I'm gonna bring my smiley face with me to the
I
slide.
see.
Yeah, so if we're over here, then Submariner is going to preferentially hit this one, you know, over and over again because it's in the same cluster. GKE is going to keep going around like this. Then if there's, yeah, randomly selecting across all of these exported backends, since these are all considered the same service.
Just clarify one thing. In your
Yeah.
graph, on the foreign one say it has 4 pod backup this service, and the current cluster has say just 1 pod backing up this service. Will it be balanced, just a low balance between, I mean, round robin between 2 clusters, so which leads to the current the 1 pod get hit 4 times more than the other pod, or it would be really low balanced?
It's against all the backends, not just against the 2 clusters, so it wouldn't like hit here over and over again.
Oh, okay.
We're like rolling around, yeah.
So all 5 of them will get low balance.
Right. It's as if all 5 of them were like equally likely.
I see.
Yeah.
Yeah,
So
which
that's
means
like the
that you're
current
more likely
situation.
to.
And then,
Sorry.
yeah, go
It
ahead.
means
Steven.
you're more likely to go to the other cluster in practice. And so I think that's the big thing where the hints sort of fall over for MCS, well, at least auto hints as they're currently defined, because inside a local cluster, you're trying to optimize for request handling capacity, and so number of CPUs or node size in some metric is a pretty good approximation of that. But then when you're crossing from one cluster to another, your costs are going to be quite different, and you probably want to optimize for something other than CPU capacity, it seems to me.
Okay, thanks.
So is the thought that we're going to have more hints, such as like things that might imply capacity as well?
Yeah, very open to proposals for additional fields. Hints is definitely something that was intended to be expanded. But right now the only field in there is zone. But certainly if there are fields or a field that would really help multi-cluster use cases, it'd be great to figure that out.
I would actually say, should that be like some sort of standard like annotation or something on an endpoint slice, rather than some hint that's maybe generated? Just I mean, that could just be generally useful information, I'd imagine.
Yeah, it certainly depends on how you're going to use it. Earlier proposals of this actually involved labels on the slice that really subset slices entirely. That ended up not being the level of performance and scalability improvements that really hoped or thought it would be. But I'm always open to other ways to accomplish that. I think a label is definitely potentially a useful way to do, or annotation, potentially useful way to do that.
Yeah, sure. I don't have a preference, annotation versus label, but yeah, labels certainly could be more helpful. Yeah, just reiterating, like it just seems like it's very much the same way that locality information is kind of fundamental. You know, you're kind of driving this specific hint just to drive that, you know, particular algorithm, but the raw data is just generally useful, and I feel like any sort of capacity information might be more in that category.
To clarify, what do you mean by capacity? Do you mean per endpoint capacity, say requests per second?
Yeah, so
anything more?
I mean, it could be a variety of things. But I guess I saw in a slide earlier, I think we were talking about number of CPUs as well as number of nodes. You know, that sort of, like if we are going to drive an algorithm with CPUs, that may be helpful. I don't know. And in terms of like, say when we are in multi-cluster, right, and we have two other clusters, say we have no service endpoints in our cluster, so we want to go to the other ones. Let's say, you know, like the two other clusters have the same number of endpoints, but one has way more CPU or something like that. You know, so we may choose to load balance slightly differently in that case.
Okay, got it. So yeah, I get the confusion about CPU and how it's used here. It is actually a relatively naive way of trying to determine approximately what proportion of traffic will hit each zone. And so it's basically roughly, and this is a very rough assumption, it's generally if you have equivalent size nodes or larger nodes, the amount of incoming traffic from, say, a load balancer is going to be roughly proportional to the number of nodes in that zone, or proportion of nodes or CPU capacity in that zone. And so the reason we're using CPU here is really just trying to determine the proportion of compute that is in that zone to determine the proportion of endpoints that we should allocate to that zone. But it's not actually, this is really just an implementation detail in an endpoint slice controller. It's not actually anything that we're exposing in endpoints or endpoint slices. It's just how we derive these hints. And there are many potential valid ways to derive hints. This is just the way that they're being derived for endpoint slices for single cluster use cases right now.
Right. Yeah. So, I mean, I guess what I see is whatever raw data you're using to determine when to generate those hints. I mean, that's fundamentally saying that, you know, a load balancer may be interested in this. And I'm just, again, thinking from Istio, like, you know, if more complex load balancers, you know, want to do something clever, it might be useful having some of that original input. If the simplistic, you know, built-in algorithm that Kubernetes comes with is going to use that, then perhaps more complicated ones will as well. But it's just a thought. But yeah, I think it's going to be one of those things like, let's play around with it and see what sort of stuff is useful.
Yeah, that sounds good. It makes sense. And I'm definitely very interested in feedback and ideas for expanding this.
I just want to time check here. We have another agenda item as well, but I think it would be great to cut over in a couple minutes to Jaromir doing a demo of the MCS DNS plugin. That's super exciting. If we could real quickly just discuss that first question that we didn't get to yet. I think, Rob, maybe you can answer this for us. What does that feature, what does that flag do for a service? Is that intended to, in the single cluster case, is that intended to enable hints, or is that intended to enable the auto algorithm?
Yeah, that's a good distinction. Right now, they're kind of one and the same. The hint scales can be set for any reason, but the only way that we set by the endpoint slice controller in the single cluster use case right now is when that annotation is set to auto. So really what they're enabling is the endpoint slice controller, again in that single cluster context, to set hints on the service, which then triggers kubeproxy to read those hints. And what I can't remember offhand is if kubeproxy will read hints regardless of that annotation. I think kubeproxy may also check for that annotation to be present.
I think it does based on me recently reading.
Okay.
So
good.
So that's a little weird for us.
Well, that kind of gives us the answer though. Like either, like I think we should copy single cluster. So if kubeproxy cares that this is set, we probably need to carry it. If kubeproxy doesn't care or isn't intended to care, then we don't, because we're obviously like an MCS implementation can add its own algorithm. That's kind of my takeaway. So I would just go with whatever the single cluster model does there.
Yeah, I think that makes sense. And if you need, or go ahead.
Sorry, I'm kind of laggy, I think, but I feel like there's a weird configuration state that can happen where we pull, like we bring this, it's not this, but we bring over that like the service has opted in, but the feature gate isn't on in the other cluster. And I don't know if that's weird or problematic.
Yeah, that's a good point. I mean, it will just be a no-op, right? It'll just fall back to a default round robin, whatever. I don't know that there's much you can do to get around that, unfortunately. It would be nice if multi-cluster could sync feature gates across, but I know that's a much bigger thing.
Yeah.
Maybe there's a few little just like flow charts of experiments worth like thinking about, so we can like warn people for MCS, like if like I do think we need to carry it over, and then I think things might occur differently than what you expect if the feature gate isn't on elsewhere. And so that can be part of the category of things where, like, similarly to if you're mirroring endpoint slices, there's some caveats, I guess. So
yeah, actually, that's a really good example. Like, things behave differently and scale is different in clusters that support endpoint slice. I mean, they've been around for a while now, but clusters that support endpoint slice and clusters that don't. But yeah, Laura, I think great idea, kind of writing out the things you might need to care about, but I don't know that we need to specifically address them. Although all this says, you know, Rob, good luck getting it to beta and on by default in 1.23.
woo.
Sounds great. Yeah, thanks so much for that great discussion and feedback here.
Yeah,
All right,
thank
thank
you.
you. I cede my time.
Thank you, Laura. Thanks everyone for participating. That was excellent. I feel like we answered some questions, so that's great. With that, let's move on to our second and last agenda item for today. Jaromir, do we have you here?
Yeah, sure, I'm here. Happy to meet you.
Awesome. Thank you for coming. This is super exciting.
Yeah,
take it away.
Yeah, so today I just want to briefly talk about the multi-cluster DNS. Let me quickly share the screen if it's gonna work for me. Yeah. Let me switch to this. So hopefully you can see my screen now.
Yes.
Cool. So yeah, as I said, I'm gonna talk about the multi-cluster DNS because this is one of the blockers. As I learned, this is one of the blockers for the multi-cluster API graduation to beta. So I actually decided to kickstart the implementation of the multi-cluster DNS. And as we discussed with Laura before, one of the ways how to do that is actually to implement a separate core DNS plugin that can be just enabled, and it would support the multi-cluster DNS spec. So that's what I published here on my GitHub. So from the implementation perspective, the way it works, it's super easy. It's almost identical to the existing Kubernetes plugin. So I actually forked most of the code. And the way it works, it runs a controller in the background, and this controller monitors all service imports and translates all queries for cluster set.local zone to those service imports. And I just want to quickly show how this can be used, because it can be just plugged into the existing core DNS. So there are actually just two steps that needs to be done to enable this. I need to modify my plugin's configuration in core DNS and add my new plugin there. So it's super simple as that. And then I just need to recompile, rebuild the core DNS, and then modify the cluster's core file to define the zone that's going to be managed by the multi-cluster plugin. And that's it. And actually, I can show you just quickly how this works live. So I hope the font is not too small, that you can read it. So I have my own service import here. So this is the important part, the only important part. it's exposed on some IP address on some and port, and I'm gonna just quickly apply to my cluster so we can use it. So okay, it was already applied before. So anyway, now I can actually exercise my core DNS. I'm running the custom build locally, and it points to the cluster. So I can use dig to send DNS requests, and I can now just follow the multi-cluster DNS spec. So for A records, we know it's the service name, right? It's a test service in my case. Namespace is my namespace. Then there is the type, and we know it's cluster set.local. Let me send this request, and I'm getting answer here. I'm getting the IP, this cluster set IP defined in the import. I can do the same for SRV, obviously following the spec. So in case of SRV, I'm getting SRV with a port as well, and I can also follow the more precise format of the SRV that's the port and the protocol following the SRV spec. TCP, right? And I'm gonna get the same. So this is for the SRV support. So far we have pretty much like full support of cluster set IPs. I have one open issue here, and it's large item to support headless services, because that's something I don't have yet. So it's still in progress. I guess my question is, what are the next steps here? Because like eventually I assume we may want to offer this to core DNS and ideally become part of core DNS. Is that true?
Yeah, I think that would be the ideal outcome. And I
Also,
don't
this
see
is
why
awesome.
not. Yeah, this is awesome.
Just want to jump
Thank
that
you.
in. I don't know if you saw our ta-da emoji reacts while you were talking and we were politely not interrupting, but this is great.
Awesome. I'm glad to hear that.
I
So-
just implemented this in Istio, so I wish I could have copied your code.
Okay, yeah. Feel free to contribute if you have the headless part.
Oh yeah, no headless.
The issue with headless is it's kind of difficult to list all endpoints for given service import when it's not part of the spec, because as we discussed before, like some implementations use the dummy service, so kind of those endpoints are actually owned by the service, not by the service import directly. So it's difficult from the API standard or the spec perspective to figure out where those endpoints are going to be.
So there should be a label on those endpoints that corresponds to the service import, as well as the.
I see. So and is this part of the API spec, or it was just?
Yes.
It should be hidden somewhere in the MCS API. Then we can dig it up for you.
Yeah.
Okay. Okay. Then it makes sense. Yeah, I guess makes it easier.
Because yeah, you should have another selector, not just the one that's owned by the service. That points to the service import that you can use to gather those.
Right. Yeah. I'll double check the spec for sure.
Yeah, so Submariner has a core DNS plugin that handles headless as well, but I'm not sure how it goes about it.
That's a good point. Yeah, I should definitely double check that one. Maybe, yeah, we can learn something there.
I think maybe this part, but yeah, we can find that. Cool. Great job.
Yeah, this is really, really exciting. If anyone has time to help with the headless, that'd be great. But yeah, let's figure out what we can do to kind of get this together.
I know there was someone at KubeCon named Aaron who was kind of interested, so I'll connect with him too. And then, yeah, it sounds like there's some other floating around implementations we might want to pull in. And then, yeah, 100% agree to get this in as like in core DNS too. so we can figure
Yeah.
out what the plan is for that.
And we've got some good friends over at CoreDNS, so I think we can help make that happen. But yeah, it'd be great to see this in tree. Thank you for that demo. That was super exciting. Cool to see.
Yeah, thank you for the time. I was happy to hear.
Thanks, everyone. I think that's our agenda for today. So again, Jaromir, Laura, thank you for presenting. This was great discussion today. Super exciting to see everyone. Happy Tuesday, and we'll see you all in a couple weeks. All right.
Later, guys.
Have a good one.
See ya.
See ya.
Bye, guys.